Hello students, welcome to first session of Chemistry of Applied Science. Let me start with the unit Metals, Alloys, Cement and Refractory Materials. In this session, let us study basic concepts of metallurgy. First, we shall concentrate on the topic metals in the unit. Elements can be classified as metals and non-metals on the basis of their properties. Examples of some metals are iron, aluminium, silver, copper, etc. Examples of some non-metals are hydrogen, nitrogen, sulfur, oxygen, etc. All of you have studied properties of metals and non-metals in lower classes. Let me limit myself to the current topic, that is metals. Now, if I ask you, where do we get the metals from? Like sodium, copper, gold, silver, etc. How do we get pure metals? Let's see now. This is the reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activities. Reactivity of metals decreases as we move from top to bottom. Reactivity of metals is the tendency to attain a completely filled valence shell. We know that atoms of the metals lose electrons from their valence shell to form cation. When we observe this reactivity series, it is clear that metals on the top are most reactive and the metals on the bottom are least reactive. So in nature, metals like gold, silver exist in the native state, that is in the free state. And the metals like lithium, potassium, calcium, sodium, etc., which are reactive, always exist in the form of compounds. Metals which are reactive combine with other elements and always occur in the form of compounds. Hence, it is clear that metal occur in nature in two states: native state and combined state. Native state is also known as free state. Inactive metals like gold, silver, platinum, etc. are found in the free state, that is in the native state. Most of the metals occur in nature in the form of their compounds like hydroxide, oxide, chloride, etc. due to the action of air, carbon dioxide and the non-metals present in the earth crust. Hence, we say that such metals exist in the combined state. So, a mineral is a naturally occurring substance present in earth's crust which contains metal in the native state, that is free state or in a combined state. Observe the figures displayed on the slide. All the figures represent minerals. Gypsum is a mineral of calcium. Chalcopyrites is a mineral of copper. Hematite is a mineral of iron. To make the concept clear, let me explain with a simple example. Consider garden soil. It contains iron, but can you extract iron from this garden soil? No, you cannot. Even though garden soil is a mineral of iron, but the percentage of iron in this garden soil is very less. It contains lot of impurities. If we want to extract iron, from garden soil, then it is a very tedious process, time consuming, not profitable. But iron can be profitably extracted from hematite, that is at a low cost with a minimum effort. Therefore, a mineral from which the metal can be extracted economically is known as ore. From garden soil, we cannot extract iron. Hence, garden soil is a mineral of iron, but it is not a ore of iron. Therefore, ores are minerals of metals from which we can extract metals economically. Thus, all ores are minerals, but all minerals are not ores. Now let us define mineral and ore. A naturally occurring substance present in earth crust which contains metal in the native or in combined state is known as a mineral. A mineral from which the metal can be extracted economically is known as ore. Observe the first figure. It represents ore of iron. Okay, it is hematite ore. Now from this ore, that is from hematite ore, we can extract iron. To make the concept of mineral and ore clear, let me consider one more example. Okay, second figure represents bauxite ore. Consider clay. Both clay and bauxite are minerals of aluminium. Okay. Bauxite is also a mineral of aluminium and clay is also a mineral of aluminium. We can extract aluminium profitably from bauxite. But we cannot extract aluminium from clay because the percentage of aluminium in clay is very less. Hence, the process is not profitable. Okay, the entire process is not profitable. Hence, we say that clay is a mineral of aluminium, but it is not an ore of aluminium. Whereas, bauxite is a ore of aluminium and it is also a mineral of aluminium. Thus, all ores are minerals, but all minerals are not ores. In this slide, let us understand the concept of gangue, flux and slag. Ores are usually contaminated with large amount of impurities such as soil, sand, clay, etc. Unwanted impurities associated with the ores are known as gangue. Gangue is also known as matrix. A substance which is used to remove the gangue is called a flux. Slag is the fusible chemical compound formed by the combination of the added flux and the gangue present in the ore. That is, flux and gangue combine to form a fusible chemical compound known as slag. The choice of a suitable flux depends upon the nature of gangue. That is, gangue can be acidic in nature or it can be basic in nature. If the gangue is acidic in nature, then we have to use a flux, which is basic in nature. On the other hand, if the gangue is basic in nature, then we have to use a flux which is acidic in nature. To understand this concept, let us consider some examples. Okay, consider the first chemical reaction. Here, silica is the gangue. It is acidic in nature. Calcium oxide is used as a flux, which is basic in nature. This silica combines with calcium oxide to form calcium silicate, which is the slag. And this slag can be easily removed during the metallurgical operation. In the first chemical reaction, instead of calcium oxide, we can also use magnesium oxide, which is also basic in nature. Okay. Therefore, if the gangue is acidic, then we have to use a flux which is basic in nature. Now consider a second chemical reaction. Here, iron oxide is the gangue and this is basic in nature. To remove this iron oxide, we use silica as a flux, which is acidic. Gangue combines with flux to form a slag which can be easily removed. Therefore, we say that the terms gangue and flux are complementary to each other. The following table shows important ores of some metals. Let us study one example from each type of ore. Consider oxide ore. Hematite is an oxide ore. Its composition Fe2O3. We can extract iron from hematite. Next, consider sulfide ore. Copper pyrite is a sulfide ore. Its composition is CuFeS2. We can extract copper from copper pyrites. Consider carbonate ore. Limestone is a carbonate ore. Its composition is CaCO3. We can extract calcium from limestone. Consider sulfate ore. Epsom salt is a sulfate ore. Its composition is MgSO4 7H2O. We can extract magnesium from Epsom salt. We have studied definition of ores, minerals, gangue, flux and slag. So, we have the ores now. Next step is to extract the metals. From the ores. The extraction of metals from the ores is known as metallurgy. That is, metallurgy is the process of extraction of metals from their ores economically and profitably. That is, at a low cost. With minimum effort. The extraction of metals depends upon nature and properties of the metal. Hence, different types of ores like sulfides, oxides, carbonates, sulfates, etc. have to be treated differently for the recovery of pure metals from them. There are 4 important steps in the metallurgical operations. First, crushing or processing the ore. Second, ore dressing or concentration of the ore. Third, reduction. Fourth, refining of the metal. We shall study all these steps one by one. This is the schematic representation of extraction of metal from ore. This is also known as flow chart. This flow chart shows the different process used in the extraction of a metal from its ore. Let me explain it now. There are 4 important steps in the extraction of metal from ore. They are crushing, concentration, reduction, and refining. Finally, we obtain pure metal after all these 4 steps. First, let us study the meaning of all 4 steps. Crushing means powdering of the ore. The process of removal of gangue or matrix from the ore is known as concentration. That is, concentration implies it is removal of gangue from the ore. Concentration is done by following methods. One is physical process and the other one is chemical process. In the physical process, there are 3 different methods: gravity separation, magnetic separation, and froth flotation. In the chemical process, there are 2 methods: calcination and roasting. Reduction is a process in which the ore is reduced to the metallic state with the help of reducing agent. Okay, therefore in reduction we require a reducing agent. We can use charcoal, coke, aluminium as a reducing agent. In reduction, there are 3 different methods. They are smelting, aluminothermic process, and electrolysis. Refining is a process of purification of a metal to get extra pure metal. To get extra pure metal. Some of the refining methods are pooling, liquefaction, distillation, and electrolytic refining. After all these steps, we obtain pure metal. We shall study in detail about all the processes used in the extraction of a metal from its ore in the next video. Were you paying attention, students? Let me test you now. Answer these multiple choice questions. See you guys again in the next session. Thank you.